Okay, good morning. Good morning. Good morning. It's September 20, 2023. The time is around, it's morning already, 3:21 a.m. Okay, my topic for this session will be the so-called remainder theorem. Okay, remainder theorem is different from the binomial theorem. Binomial theorem is actually the expansion of a binomial term, but for the remainder theorem, it will be the so-called division of a polynomial by a single term. Okay, let's proceed. The topic for this morning will be a long video format discussion, and this is still college algebra, lesson number 67. We are almost done with college algebra. Okay. The title of the topic will be the so-called remainder theorem. And what's the importance of the so-called remainder theorem? Okay, later on, I will show what's the importance of the remainder theorem, but for the concept of the remainder theorem, it will be something like this. When a polynomial f of x is divided by a term x minus r, the remainder is actually function of r. Or if we try to bring this out in terms of an equation, function of x divided by x minus r is equal to function of r. There could be some, what you call this, derivation of this, because like the binomial theorem, the expansion is actually derived by the author of that one, but in here, the remainder theorem, he just brought out the equation for finding the remainder of a given function, if that is to be divided by a single term x minus r. So I will try to repeat it. The given function of x divided by, function of x is a polynomial. Polynomial is actually a term that contains many terms, right? So it could be 2, 3, 4, or 5. So polynomial is an expression that contains many terms, right? So meaning a polynomial f of x divided by x minus r, according to this theorem, it will be equal to function of r. Let us prove this one when we try to solve this problem. Okay, I will not bring out the derivation of this, even the derivation in the book is not given. Right? Okay, let's try to bring out an example problem to visualize the importance the importance of the given equation. Okay, example number 1. Use the remainder theorem to find the remainder when the given polynomial is f of x is equal to 72x squared plus 284x plus x plus 2. No. Oh yeah, just that one. 72x squared plus 284x minus 160. The continuation is here, minus 160. When this given polynomial is divided by the term x plus 2. The problem is just asking for the remainder. And according to the remainder theorem, there's a shortcut solution on how to bring out the remainder of this one by not using long division. Okay? Let's try to bring out the solution by using the remainder theorem. We will place here x minus r. We equate this x minus r on the given equation by the value x plus 2. X plus 2 is actually the divisor, right? So we will equate x minus r to be equal to x plus 2. So in here, x minus r is equal to x plus 2. Am I still on camera? Right? So in here, if x minus r is equal to x plus 2, this x here will cancel, right? Okay? So minus r will be equal to positive 2. Multiplying both sides by negative 1, r now will be equal to negative 2. So actually, after the equating of this one, we have computed for the value of r, and this is actually equal to negative 2. Okay? Since r now is negative 2, because according to the remainder theorem, as soon as we compute for r equal to a certain value, we will try to substitute this value here to the given polynomial, then try to simplify, and supposedly what will come out will be the remainder. So, by following the given polynomial, function of x is equal to 72x squared plus 284x minus 160. We replace all x by the value r equal to negative 2. So, function of r now, meaning the value of the polynomial when x is equal to negative 2 will be equal to, okay, that will be 72, right? R is negative 2, this will be negative 2 squared. Am I still on camera? Plus 284 multiplied by negative 2, I'm following this, minus 160. If we try to simplify this one, this will be 72 times 4. This is now a positive negative, this will be negative 568 minus 160. This is 288, 72 times 4. Minus 568 minus 160 is actually negative 728. So 288 minus 728, our remainder should be a negative value, and the value is actually negative 440. So the value here, the remainder that we are looking for, sorry for this one, I will try to get my green pen. The required remainder is actually equal to negative 440. As simple as that one, okay, by using the remainder theorem. So actually, the remainder theorem is a shortcut method on how to find the remainder of a polynomial divided by a certain value x. Okay, so the answer for number 1 will be negative 440. So how could we check the validity of this answer here? To check the validity of this, I will go with the long division, because the normal solution is the long division, right? But since we are studying algebra, and algebra is there are solutions which are a shortcut of certain long solution. So to eliminate this long division, actually they formulated this the so-called remainder theorem. But for me, I prefer the long division because I don't have to memorize a certain formula. I just divide it myself. Okay, let's proceed with the checking of the validity of the answer. We will rewrite the given numerator, 72x squared plus 284x minus 160, divided by x plus 2, right? So if we try to divide it, long division, right? The first dividend here, the first answer on top will be 72x. So 72x times x, that will be positive 72x squared. And 2 times 72x will be 144x. And if we try to subtract, okay, this 72 cancels, right? Because the operation is subtraction. So 72x squared minus 72x squared, it will be 0. Okay? 284, we will subtract this 144 here. Since the operation is subtraction, this will now be negative, right? So actually a plus and a minus, but this is bigger. So 284 minus 144, that will be positive 140x, right? The positive number is bigger than the negative number, so the sign will be plus. This is 140x. We bring down this one. This is negative 160. Okay. Let's try to find for the next answer. Okay. It should be 140 because this is 140, right? So 140. It should be 140 times x will be 140x, and 2 times 140 will be plus 280. Again, try to subtract, right? So 140x minus 140x, this will now be minus, right? A plus 140 minus 140, they will try to cancel out. And the operation is subtraction here. So this 280 now will become negative 280. Okay, so this is negative 160, negative 280. So we are adding two negative values. So the magnitude is just the sum and the overall sign will be negative. So 160 minus 280 is actually negative 440. And this is actually the remainder, 440. Same as this one. So we place it here, it is true. Meaning the answer negative 440 is correct. That's why we place it to be true. Oh, that's the solution by using the long division. For me, I prefer the long division. Why? I don't have to, supposing I forgot the remainder theorem equation, then I cannot solve it anymore, right? But for the long division, as long as I know how to long divide a polynomial by a certain value, I could divide it. Right? Okay, example number 2. Still, same problem. Same variation of problem. Okay, but different polynomial. Use the remainder theorem to find the remainder if the given polynomial is f of x is equal to, a little bit complicated. This is with the highest power 3. So this is a cubic equation. 2x cubed plus 3x squared minus x plus 4 to be divided by the single term x plus 3. Okay, the problem is asking if we try to divide this long polynomial divided by x plus 3, what will be the remainder? Okay, first solution is by using the remainder theorem. Again, we will equate x minus r and this should be equal to x plus 3. Like what I said a while ago, if we try to equate this x here cancels. So negative r will be equal to positive 3. Okay, multiply both sides by negative 1. So this will now be r. And the right hand side will be 3 times negative 1. This will be negative 3. So the value r, which is needed in the remainder theorem formula, is r actually equal to negative 3. And according to the remainder theorem formula, the remainder is just the value negative 3, okay, when we try to substitute for x in the given polynomial. So f of negative 3, the value of the polynomial when x is equal to negative 3. This should be 2 times negative 3 cubed, right? Plus 3 multiplied by negative 3 squared minus open quantity. This is x, right? The operation here is subtraction, but the value we are inserting is actually a negative value. So we must have to place a quantity here. So minus open quantity negative 3 plus 4, the last part. Then try to simplify. Negative 3 cubed is actually negative 27 because the exponent is on odd number, right? So negative 27 times 2 will be negative 54. Negative 3 squared is positive 9 times 3, that will be positive 27. This is minus 3, it will now be equal to plus 3, plus 4. That's why I place the quantity here, because the operation here is subtraction and the number we are inserting is also a negative value. So it's actually very dangerous without placing the open and close quantity. So minus open quantity negative 3, that will be plus 3 plus 4. Then try to combine similar terms or combine all the positive terms. 27 plus 3 plus 4 is 34. This is minus 54. Minus 54 plus 34 are actually we are adding a negative and a positive number. The negative number is higher, so the overall sign is actually negative. Then we will just subtract the magnitude. 54 minus 34 is 20. It should be negative 20 because the negative value is actually higher. So the remainder of this problem here is actually negative 20. Okay, by using the remainder theorem. Let's check. Again, by using long division. I don't mind using the long division. Okay? So we will write the numerator 2x cubed plus 3x squared minus x plus 4, it's this, divided by x plus 3. The first dividend will be 2x squared, right? So 2x squared times x, it will be 2x cubed. X and x to the first power, this is x squared, it will be x raised to 2 plus 1, which is 3. So this will be 2x cubed. 2x squared times 3 will be plus 6x squared. Okay? Then try to subtract. The operation is subtraction now. 2x cubed minus, okay, 2x cubed, so this will now be negative. If we try to insert the negative sign, so actually this negative 2x cubed cancel with this, because the operation is subtraction, right? And 3x squared, the operation is subtraction, minus 6x squared. So this negative value is higher than the positive one. The overall magnitude will be 3, but the sign should be negative. With the multiplier, x squared. This is under the column for x squared, right? We bring down x, we bring down 4. Okay, so this is the next numerator. The next dividend now will be negative 3x. And negative 3x times x will be negative 3x squared. Negative 3x times 3, excuse me, negative 3x times positive 3 is negative 9x. Again, try to perform the operation subtraction, right? So, minus 3x squared minus minus, this will now become plus, right? Minus 3x squared plus 3x squared, the operation is subtraction, so this cancels, right? This is now 0. Minus x minus minus 9x, so this will, 9x will now be plus, because the operation is subtraction. Minus x plus 9x, so it's positive 8x. Okay, we bring down 4. The next dividend now will be, this is x and it got a coefficient 8, right? So it will be 8. 8 times x will be 8x. 3 times 8 will be positive 24. And again, try to perform the operation subtraction. 8x minus, this is positive x. So if the operation is subtraction, this will now be minus. So plus 8x minus 8x, they try to cancel out. The sum is 0, right? This is positive 4. The operation is subtraction, this will now be negative 24. Then here, we are adding a positive and negative number. The negative number is larger, so the overall sign of the answer will be negative. So plus 4 minus 24, sorry for this one, they should be 20. Right? So this negative 20 here is same as this, so it is true. Okay, as simple as that one by using the long division. Okay, that's it guys. That's the so-called theory or the so-called remainder theorem. That is, I will repeat it for the last time before we go for this morning. A polynomial f of x divided by x minus r according to the remainder theorem. Okay, I don't know who invented this one. And this should be equal to function of r. Okay, this is the required equation. Or if you want to check the validity of your answer, use long division. And what will come out supposed to be will be the same. Okay, good morning from Los Angeles. Professor David J. DeLosReyes.